Hello once again. Thank you for joining us. This is the Space Nuts Podcast, episode number 244. Oh my goodness. I was listening to someone the other day skite about their 200th episode of whatever podcast that they do, one of the Australian national television networks. Oh, we've done 200 episodes. We've done 243.1.
Yes,
so there.
Exactly.
And there are many who have done a lot more than us.
It could all fall over at any second, Andrew. You and I are both
always
well aware.
Possible.
Yeah.
Yes. And, of course, you've heard from him already, my partner in crime, Professor Fred Watson. Hello.
Morning, Andrew. How are you today?
I am well, sir. We're anticipating rain. It's going to be very windy for the next week. We've reached that time of the year where the wind starts to whip up as the season changes. We find this time of year very, very windy, so I'm not looking forward to that. I'm not a wind person. Never have been a wind person.
Yeah, my wife isn't a wind person either, but I am. I like a bit of wind. We've got the rain already, actually. There's showers going through from the sea.
How did you get it before us?
Well, it's coming,
in from the sea. Ours is coming in from... Yeah, ours is coming in from central Australia, so it's coming in from the northwest out of Queensland, and in fact, the system that's coming through is crossing the entire continent, which is extraordinary. You don't usually see that kind of a system, but yes, indeed, we're looking forward to this. It'll just, I think, a lot of places are going to get their monthly average in the next 2 days, which is yay. We've certainly broken the drought. Now, coming up on this episode of Space Nuts, Fred, we're going to discuss the probability that exo-asteroids could be quite common, not just one or two space doogies. We're getting dumped on from a great height, as it turns out. There's also a new twist on supermassive. Yeah, sorry about that. A new twist on supermassive black holes. And we're going to tackle a couple of questions. Someone's asked a question about Planet 9 and Spiral Galaxies. It's all on Space Nuts this week. And thank you for joining us, by the way. But before we get to all of that, Fred, little update on NASA's Perseverance rover. Has it moved another 2.5 meters, perhaps?
No, I don't think it's moved yet again. But what they've done now is, 6.5 meters. Come on, what more do you want?
That's impressive.
Yeah,
I want to lap around the globe. That's what I want.
I think that'll be coming, I'm sure. So what we've seen, though, is the testing out of a facility which is really super impressive. It's got a name that's super as well. It's called SuperCam. And SuperCam is mounted on the mast of Perseverance, and can sort of swivel around and look at things, but it can do 5 different sorts of analysis, whatever it's looking at, to study the geology of Mars. And basically, it'll be one of the things that will assist scientists in choosing what samples to cache in order that they can be brought back to Earth later on. So they've been doing health checks on SuperCam and all its systems, and apparently everything is in super duper working order. One of the things that's part of SuperCam is that microphone that we heard sounds from before. You remember we heard the sound of the wind on not long after touchdown. Actually, we got that recording. But they've recorded something a little bit more Earth-like. The sound of their laser zapping the rocks, because this SuperCam has a laser that zaps the rocks, and what you do is that then the sort of little plume of gas that comes off the rock is analysed by the other instruments on board. So and they confirm,
yes, it's a rock. We found
a rock. But is it a rock that contains all those building blocks of life that we're looking for, and perhaps even signs of, amino acids and things of that sort, or even proteins? Anyway, that's all very exciting. But NASA did send out a recording of the laser zapping the rock, which I don't have to hand, but I can tell you what it's like because I can do it. It just goes. Did you get that?
Of course, yeah. Yeah,
that's what
I had a similar sound years ago when I was getting my eyes lasered.
Yeah, that's right. It's the same sort of thing.
As you can see,
a bit more powerful.
It worked. Still wearing glasses.
Yeah. Still wearing glasses. Yes. All right. Anyway, so that's that's a big step. It is. People are very excited by it. There's a few places where you can find some of the images that it sent back.
Some of them are spectacular, Fred. The high definition images are incredible.
That's right. And these are pictures of the rocks that they're looking at, which look just like rocks. But, when you see the detail on them and you think, my goodness, that's on Mars. This is just astonishing. So it's great.
Yeah, it is indeed. And we'll continue to report in on the progress.
Yeah, we will. All good from Mars.
Yeah. Yes, and at the rate we're going, by the time we get to episode 344 of Space Nuts, Perseverance will have moved maybe 9.2 metres. Who knows? Could be.
Look, I hope nobody from the Jet Propulsion Laboratory is listening to this, Andrew.
Yeah,
casting aspersions on their driving skills. It's a mistake always to do that.
I hope they know we're joking, but I'm told that a lot of people overseas don't get the Australian sense of humour because self-deprecation and sarcasm are, pretty commonplace.
Quite right.
I love it. I do. Okay, let's move on to the next topic. And this is one of my favourite topics, as you alluded to in your email when you sent me these. It's the space doogie. Back in the news, and the probability that these things are being flung at us from other solar systems on a regular basis. How so?
Well, it's actually earlier studies before Oumuamua, which you always refer to as the space doogie, whatever. I still think it looked like a breadstick, Andrew.
Yes,
I'll stick with that.
The space baguette.
The space baguette, of course. Mais oui, c'est très bon. So studies before that was discovered suggested that we would, from time to time, be visited in the inner solar system by objects from other solar systems, basically things that had been slung out of their own solar system and had wandered through space for a few million years, and then they passed through ours, never going near enough to anything to be caught by its gravity, although it's possible that could happen, accidentally. If one of these things came near enough to Venus or the Sun, it could end up being a satellite of Venus, which would be good because it doesn't have one already, or a planet of the Sun. That's not happened, and the odds of that are very, very low. But the odds of something coming through the solar system from time to time are much higher. These things are called ISOs, or interstellar objects, and they basically, that's what characterizes them. They don't belong to our solar system. Sometimes they're called exo objects or exo bodies.
Yeah.
So when in fact there were two events, Andrew, because it was 2017 when Oumuamua came through, but then actually less than 2 years later, the second interstellar object came through, and it's a comet called Borisov, discovered by Mr. Borisov in, I can't remember where he is, Ukraine or Russia. That discovery told us that comets do it as well, because that was definitely a comet. When it got near the sun, it started beaming out plasma that comets release. And in fact, an analysis was carried out on those that showed that actually the comet has the same sorts of materials as we find in comets on the Earth, in the solar system. Sorry,
we don't want to find a comet on Earth.
There are many comets on Earth. There might be the debris from them, the remnants of comets. That might be what makes the oceans. But anyway, But the fact that now we've seen these two means you can put a much bigger emphasis on, or get a much better idea of how frequently they might turn up. And that work has now been done. There is an organization called, it's I4IS, which stands for Initiative for Interstellar Studies, sometimes written as I4IS with the number 4 in between. Initiative for Interstellar Studies, which is really sprung from this. But members of that institute and a number of other institutes have done this research on looking at how many of these things might fly in. There's a lovely quote that I want to read to you because it is really, I think, quite stirring. It comes from Marshall Eubanks, who's the chief scientist of a number of different private companies, space initiatives and asteroid initiatives. You can tell where these things are going. But this is a lovely quote. He says, just by proving that they exist, in other words, because these two things came through the solar system, it has had a profound effect, creating a field of study almost from nothing. And it's a field that funding authorities are just beginning to recognize. Interstellar objects provide us with the opportunity to study and in future literally touch exobodies decades before the earliest possible missions to even the nearest stars, such as Proxima Centauri. So, it's stirring words, and I react to that. I think it's quite true. These things provide an opportunity, if we can have the wherewithal to grab one, or at least to do a flyby of one, to put all these, like the supercam type instruments on it and see what these things are made of and do all the rest of it. So there's a number of different kinds of missions that are proposed. But before I get to that, let me just mention that the studies now indicate that round about 7 of these interstellar objects probably pass through the solar system every year. And the issue is detecting them. You've got to pick them up. And that's we can do that now because we've got this I was going to say flotilla, but they're not floating, array of near-Earth objects, telescope discoverers and trackers, things like Pan-STARRS 2 up there on Haleakala on the island of Maui, instruments of that kind, which are able to look for objects moving through the solar system. Usually they're objects belonging to the solar system, but they can pick up these others as well. So I think the estimate now is around about 7 interstellar asteroids per year, but only about 2 interstellar comets a year. They're rarer. And perhaps it's partly because of the dynamics of comets. I mean, comets normally hang out on the boundaries of solar systems and occasionally get disturbed to fall in. The thing about comets is, generally speaking, they're very small. The nucleus of a comet is only probably seldom more than 20 or 30 kilometers across. And that then forms this beautiful tail when it gets near the sun. Asteroids round about the same size are probably brighter. Comets are very dark on the surface as well. So anyway, whatever the deal is, it looks as though there are enough of these to really think about how you might intercept them, how you might, basically further our research on them. There is actually another quotation, I think again from Dr. Eubank. We assume that ISOs come from or are formed with stars and their planetary systems, and that after they are on their own, they share the same galactic dynamics as stars do. In other words, this is how you start doing the statistics for how these things might swirl around the galaxy. We use the 2 known ISOs, One-Eye Oumuamua, and the One-Eye refers to it being the first interstellar object detected, and 2-Eye Borisov, and the efficiency of past and current astronomical surveys to estimate the number of these objects in the galaxy, and stellar velocity estimates from the Gaia mission. That's a mission that looks at the positions of stars very accurately to estimate the velocity spread that we should expect. And as I said, they think there might be 7 asteroids coming in per year, and two perhaps, actually, I beg your pardon, they dropped that statistic. It's not 2 per year, it's once every 10 to 20 years. So they are much rarer.
Oh, right. That's comets, you mean? Yeah. Okay.
Fascinating stuff, though.
Yeah, it is. I'm just wondering how they differentiate between local comets and asteroids, ones that are within our solar system and the ones coming from the outside that are being flung at us by people who obviously don't like us very much. But is it all about the angle? Is it all about the angle of attack or the speed or
it's
those sorts of things?
Actually, the angle's less important because comets, long-period comets, come from all angles.
Right.
That's because they come out of the cloud, which is sort of wrapped around the solar system. But the key thing is the speed, because these two objects were both travelling at speeds that could not have bound them to the solar system. In other words, there was no way they were ever going to stop and go into orbit around the sun. I think Oumuamua was round about 26 kilometres per second, its highest velocity, which is very much, it's above the escape velocity of the solar system. So it comes and goes.
Yeah. I think it's more a case of it's gone, oh, look, there's Earth, accelerate. And
maybe that's right. Well, that was the thing.
In a flurry.
We've still got this puzzle that it did seem to have some non-gravitational forces acting on it, which are thought to be perhaps ejected material coming from it that have boosted it in a particular direction.
Although there is still the theory that it might be alien. That one's still being considered.
That's Avi Loeb's idea that it's and he's just published a book about that.
Yes, he
which
has.
is probably on its way to be a bestseller.
Probably.
I think what they've suggested, just not going into detail on this, but how do you intercept them? And one way is to have things, and I think we've talked about this before, have things orbiting in space that are just spacecraft that have got mega kind of Lamborghini rocket booster attached to them, and they're just waiting in orbit for something to go past. I've seen suggestions where you might have 3 of these spread around perhaps the Earth's orbit, and then once you've sighted something, you hit the button, send it off in the right direction to chase after whatever it is, and see if you can get a photograph, which would be a good start. It would be fantastic to have an image. I mean, it would certainly solve the issue of whether Oumuamua is an alien spacecraft if we could have got a close-up photograph of it.
Yeah, well, it's being chased by a Tesla, so you never know what it was going to be, wasn't it?
No, well, that's right. That was, there was, I think Elon Musk did look closely at whether they could mount a mission from SpaceX hardware to chase after it, and it just was not possible. They would never catch it. No,
I think that's been part of the problem so far. These things have passed us before we've realised they were there. Yeah. I mean, we were asleep for Oumuamua because it was Christmas, and we just went, oh, what? We really need to probably find them before they get here, just in case they're getting a bit too close for comfort.
Yeah, that's right. Actually, Borisov was detected before it entered. Yeah, before it passed the Earth, or its closest. But even that, the speed was too high. But it did mean astronomers could get a good look at it, which is why we know it had these various chemicals in its coma. Yep.
Okay. Well, keep your eyes peeled. They're coming in thick and fast.
Yeah,
they are, indeed.
Right.
This is the Space Nuts podcast with Fred Watson, that's him, and Andrew Dunkley. Welcome back. Thanks for listening to the Space Nuts podcast on whatever platform you choose. You can find us just about anywhere these days, whatever your favourite podcast distributor is. Yes, thanks for listening or watching if you're a YouTuber. And if you're a supporter of the Space Nuts podcast financially, we just want to send out our thanks. We've had a few more people sign up in the last week or so through Patreon and Supercast. So thank you for doing that. It's just a couple of bucks a month to put into the kitty. We are aiming, of course, to make Space Nuts totally and utterly user-focused, user-supported or listener-supported, rather than going down the commercial line, which is what we're doing at the moment. But, in time, if we can get, maybe 1,000 patrons, it'll all be about us. We'll just look after each other, and that's what we're moving towards. So if you'd like to become a patron, you can do that through our website, spacenutspodcast.com, and up in the top right-hand corner, there's a button called Support Space Nuts. Took us a long time to think of a name for that button, but after many committee meetings, that's what we decided upon. Support Space Nuts. Click on that, and the different options will pop up on your screen. Choose whichever one you want. You can, if you want to make a donation, you can do a one-off donation through PayPal as well. So it's totally up to you. But to those who have signed up and are dropping a few dollars in the bucket every month, thank you. Greatly appreciated. Now, Fred, let's move on to our next topic. And this is one that, once again, we're going to be talking about black holes because they are the most mysterious things in the universe. And, you know, people have got all sorts of theories about them. We're only just now starting to create images of them. And now we've discovered that there might be another piece to this fascinating puzzle of supermassive black holes. What have they found out now? And is it scary?
Black holes are always scary, Andrew. It is that black holes can move. They can actually take on a movement of their own. And that, I guess, makes it even more scary because it conjures up the idea of things moving through space which are independent and able to do their own thing. But it's not actually quite as bad as that. What we have is some research that has been done on whether the black holes at the centers of galaxies, and we know they're supermassive black holes because we've discussed those many, many times. We think most galaxies have a supermassive black hole at their center. Whether those black holes can actually move independently of their host galaxy. And that's something that's a little bit counterintuitive because the reason why this thing's sitting at the center of the galaxy is because it's not moving. Everything's kind of swirling around it. But astronomers at the Center for Astrophysics at Harvard University, they've actually found an example of a supermassive black hole that is moving relative to its parent galaxy or its host galaxy. So there's a really nice quote that actually sums it up. I'm always very happy to quote the scientists who are doing the work here rather than making up my own words. This is Dominic Pearce, who's an astronomer at the Center for Astrophysics at Harvard. He is actually the leader of the study. He says, we don't expect the majority of supermassive black holes to be moving. They're usually content to just sit around. But he says they're just so heavy that it's tough to get them going. Consider how much more difficult it is to kick a bowling ball into motion than it is to kick a soccer ball. Realizing that in this case, the bowling ball is several million times the mass of our sun. That is going to require a pretty mighty kick. And so what they've done is exactly that. They've looked at a galaxy, and in fact, they surveyed 10 galaxies and looked at the black holes at their cores. And I'll put a bit more detail on that in a minute. But the galaxies, you know, they're fairly easy to measure their motion. You basically just use an optical spectrograph, the normal way that we do measure the movements of galaxies. You've essentially got to filter out what we call the Hubble flow, which is the movement of a galaxy because of the expansion of the universe. So they did that for 10 distant galaxies. But the black holes are a different kettle of fish. How do you measure the velocity of a black hole when you can't see it? So what they have to do is look at the accretion disk. That's the swirling disk of material that is around the black hole, swirling around and being sucked in. And they specifically looked for black holes whose accretion disks contain water. Now, it's probably vaporized water, but it's H2O. And as that water gets excited, it does something very similar to what a laser does. It becomes something called a maser. And a maser is, laser is light amplification by the stimulated emission of radiation. That's what it stands for. Sorry about all the cockatoos there. joining into the sort of story. I've got the door open. I probably shouldn't have. I think they're coming in the room, actually. Lasers,
for those who don't... Sorry, I just want to explain, for those who don't know, cockatoos are big white galah-type birds with a sulphur crest on their heads, and they get very excited and they screech.
And there's usually gangs of hundreds of them.
Yes, usually in their hundreds.
What's happening here.
Yeah, we've got a lot of them out here too.
I think they're moving away. Okay, a bit of peace and quiet while I finish the story. So what's a maser? A maser is the same thing, but with microwaves. In fact, masers came first, actually, back in the 50s when these things were being developed. Maser is microwave amplification by the stimulated emission of radiation. And it's a similar phenomenon to a laser. You get this, basically, a beam of radio waves. And that allows the radio antennas of, any set of radio arrays. Usually they use something called VLBI, which is very long baseline interferometry. You can actually measure that velocity with great accuracy. And so that's what they've done. They've used these masers to measure the naturally occurring masers to measure the velocities of the black holes, compare it with the velocity of the galaxy, and 9 out of the 10 were at rest. The black holes were sitting, doing nothing much, as he said, at the centre of the galaxies, but one actually wasn't. One was moving at 50 kilometres per second relative to its parent galaxy. So the next issue is, okay, what's causing it to move? And one of the other scientists working on this project, Jim Condon, he's a radio astronomer at the National Radio Astronomy Observatory in the United States. He says one possibility is we may be observing the aftermath of 2 supermassive black holes merging. The result of such a merger can cause the newborn black hole to recoil, and we may be watching it in the act of recoiling or as it settles down again. So that's that's something that ties in with the work that people have done in gravitational wave astronomy when we see black holes merging. But the other possibility is that you might be looking at a black hole that's part of a binary black hole, 2 black holes orbiting around one another. And what you might be seeing here is a black hole, one of which has the accretion disk, so it causes the maser radiation, but the other doesn't have that. And it's a much quieter one. And so you don't see the effect of the second black hole. You've got one that's visible and one that's not. And it might be only the motion that tells you that they are 2 parts of a binary, two parts of a pair of black holes that are gravitationally connected. Really interesting stuff. It will need many further observations, I think, to find out what's going on. But it's really quite a new line of study. I mean, we've talked about black holes ad infinitum over the last 40 years, or however long Space Nuts has been going. But we've never talked about them moving around inside their galaxies.
No, but I suppose when you consider that just about everything in space is moving for one reason or another, it makes sense, doesn't it?
It's not a surprise.
Why shouldn't black holes move too? The fact that they merge from time to time says one of them's moving at least.
Yeah, that's just
or the whole galaxy in that. Yeah. So. Yeah, it does. It shouldn't really come as a big surprise, but how many and how often and what's causing it, I suppose, is going to be the subject of future speculation and study and ultimately confirmation, I guess. But yes, so it's what, 1 in 10, you said?
That's right. 1 out of 10 is moving. Yeah.
Okay, and sounds like one of the ones they've discovered is moving quite fast, which.
That's right.
A little disturbing, but it's too far away to worry us, I imagine.
Absolutely, yeah. So, in fact, this is only 250 million or thereabouts light years away. It's a long way off. But just to point on that, when black holes merge, and we know this from the gravitational wave detections, when they do this final spin around each other, they're approaching significant fractions of the speed of light when they're doing that. So they become highly relativistic, as we say. Yeah, really.
Well, it's not surprised there's some residual momentum if they're doing that.
That's right, exactly. Yeah, so after they've collided at nearly the speed of light, you'd expect a little bit of a wobble, a mere 50 kilometers per second.
Well, I think I like my terminology, residual momentum. You can use that if you like.
Yeah, okay. I think somebody should use that. Yes.
All right. Watch this space, as we say, because there might be more on this in the future as they unravel the mysteries of black holes. You're listening to the Space Nuts Podcast, episode 244, with Andrew Dunkley and Fred Watson. Well, thanks for supporting the Space Nuts Podcast, and thank you for listening on whatever podcast platform you choose. We're on many these days, and I think you can find us just about anywhere. And thanks to our YouTube followers. I would have thought our numbers would have declined, Fred, once we started putting our faces on YouTube, but they've actually gone up. I think we've got 1,620 followers on YouTube now, which is very exciting. So, thank you for following us on YouTube. Thanks to those who've recently joined the Space Nuts podcast group as well on Facebook. That's a group that was created by the Space Nuts audience, and it's a place where you can join like-minded people and discuss your interests in astronomy, and swap ideas and maybe ask questions and get some thoughts from your fellow Space Nuts. That's the Space Nuts podcast group. Of course, we've got the official Space Nuts Facebook page as well, which is growing in numbers. So join them all. Just log into everything. Why not? Just become a real Space Nut then. Now, Fred, we have got some questions. So let's go firstly to the University of Arizona.
Hello, Fred and Andrew. This is Weston from the University of Arizona in Tucson. I was listening to a recent podcast where the topic of Planet 9 came up once again. And I know the reasoning that people think Planet 9 might exist is the elongation of the orbits of the trans-Neptunian objects. I was wondering, since this is not a universally accepted theory, what are some other explanations for this elongation of orbit? It just seems really odd to me that there would be an irregular orbit if there were nothing out there. Love the show, guys, and keep up the amazing work.
Well, we'll try, and when it becomes amazing, we'll let you know. Thanks, Weston. I like Weston's name because when I was a young bloke, I used to play soccer, for those in the UK, football. And we played against a team called Weston. And, they used to beat us too. They were pretty good out there in the Hunter Valley coalfields with the likes of Cessnock and Curry Curry. I played for a team called the Tanambit Sharks, which was weird because Tanambit's nowhere near the ocean. But we were the Tanambit Sharks. Our colours were red and blue. We weren't very good. But I was with the first team that was created. It was a brand new club when I joined it, and you've got to start somewhere. But thanks for the question, Weston. Planet 9 we've talked about many times before. There's been all sorts of theories. One of the more recent theories is there is no Planet 9. It's just a whole bunch of other stuff acting like a planet. So, one wonders what is causing all this influence, Fred?
If there's any influence to be caused, because Weston's put his finger on it, really, that it's still a controversial idea that we have these what are called extreme trans-Neptunian objects, and it's really only a handful of them. I think it's, less than a dozen, that have an alignment because their orbits are very elongated, and it looks as though the elongation of their orbits is all in a particular direction. And the original suggestion from the scientists who proposed this, and a number of them actually, Mike Brown is one, Chad Trujillo is another, these scientists said that alignment must be due to the influence of a planet which we haven't discovered yet, a very distant planet, and that's what we call Planet 9. So this has been looked at in great detail now because I guess you could say there are two camps in this whole business. The ones who say there's nothing there, the ones who say there's something there. And there are a few people who suggest that it might be a black hole rather than a planet, a primordial black hole. That's another thing that's popped into the mix. But work that I think we talked about not very long ago, which seems to me to be worth taking into account. And it comes from a group of scientists who've conducted what they call the Outer Solar System Survey, or OSOS. And what they've done is looked for more of these extreme trans-Neptunian objects. I think they looked in detail at 8 new objects, all with very long semi-major axis. That's the distance, essentially the length of the elongated orbit. Well, it's half the elongated orbit length, which is why it's called the semi-major axis orbit. The semi-major axis. So they've looked at those and they found some that are not particularly aligned in the way that the original scientists looked at. And then they've done all kinds of statistical studies to try and account for the observational bias, which is always something you've got to be careful for when you're doing statistics. You've got to look for biases. Maybe you only observe at one time of year, or maybe you're keeping away from the Milky Way, or whatever. Those biases creep in. And when they account for those, they find that in fact, to quote, the orientation of the orbits of the objects with the largest semi-major axis was statistically consistent with being random. In other words, the alignment disappears. I mean, the alignment's still there, but what they're suggesting is that we're not seeing the whole picture. Because of our biases. We're not seeing exactly what is being told, and what's being told might be that there's just no clustering at all, that they're distributed right around the sky. Basically the parameter that defines the direction of the alignment of an orbit is something called the argument of perihelion, which is a great name, because arguments are used in a different way there, but there's certainly plenty of arguments going on in the astronomical community. So that perhaps is the main one, but there are several other explanations that people have proposed for these, alignments, whether they're real or not. And there's still work going on in trying to find Planet 9, if it's really there.
So bottom line is we could be looking for nothing.
We could be looking for nothing, or we could be looking for something in the wrong place, or there's something that we could be looking for isn't what we thought it was. Yeah, it's a pretty wide open question.
Well, I suppose if we keep looking and never find it, we'll ultimately have to conclude there's nothing, but...
Yeah, I mean, you might be able to rule it out. For example, as more of these extreme trans-Neptunian objects are discovered, and they will be because we've got bigger telescopes now. Wait till the Vera C. Rubin Observatory comes online. That's the 8-meter telescope that'll survey the whole sky in I think every 3 or 4 days. It's astonishing. Wow. When that comes online within the next year or so, then we'll start seeing many more of these, and it's possible that the whole thing might then disappear, that you find that they're completely random in their orientations.
Okay. Now, before we move on to the next question, Weston said he was from the University of Arizona in Tucson. Now, I understand you've been there, and it's a pretty special place.
Yeah. Many times, actually. It's a hotbed of astronomy, partly because right next door is the National Optical Astronomy Observatory at Kitt Peak. That's not very far from Tucson. But Tucson has an astronomy department. It's called the Steward Observatory, which has many very fine astronomers working there, including some friends of mine, one particularly good friend of mine who I still keep in touch with. We were PhD students together at the University of Edinburgh, and he went on to become a professor of astronomy in Tucson. He's done some great stuff, actually. He's written some fantastic books about life beyond the Earth and things of that sort. Chris Impey is his name. Hello, Chris, if ever you listen to this. But yes, he's there. And something else that's there at the University of Arizona is the Arizona Mural Laboratory, which is where the mirrors are being made for the Giant Magellan Telescope, 7 8.4 meter diameter mirrors. and they're being cast in the rotating oven at the Mural laboratory, and and that's where they're being polished as well. And that is located inside one of the buildings. It's the stand, actually, the stand that people look, I think, for the baseball field.
Wow.
I might have the wrong sport there. But yeah, it's a huge concrete structure which is very stable in temperature inside and empty, because it's all, it's tiered staircases and tiered seating. So they've occupied this with this gigantic Mural laboratory. It's well worth a visit if ever you're in Tucson.
Wow, how amazing! I'm glad Weston got in touch with us to be able to.
Me too.
Thanks for your question, Weston. Hopefully we didn't answer it for you, because there isn't an answer yet. But maybe one day. Let's continue on. This one comes from Poland, but it could be Kentucky.
Hey guys, I'm Robert. I'm originally from Kentucky, but these days I live in Poland. My question is pretty simple, but I think the answer might not be, and that is, what causes the spiral in a spiral galaxy? Thank you very much. Really looking forward to the answer. Y'all take it easy.
Yeah, you take it easy too. Thanks, Robert. It's caused by a fairy floss machine, cotton candy machine. Is what causes the spirals. That's my theory.
Well, for a while that was as good as any. Because they present a puzzle, actually, the spiral arms, and it's one that took a lot of sorting out, and it's one of those things where the sorting out took place within the time span of my career. So I remember when we were fooling around with all kinds of wild and wonderful theories, but it's now well understood. And the fact is that when we look at galaxies, we see these lovely, lovely swirling patterns. Some of them are very symmetrical, almost perfectly symmetrical, looking, as if they've been painted. So the question is, what are they made of? And your first thought is obviously, well, they're just strings of stars that are kind of wound up by the rotation of the galaxy. But you don't have to work very hard to prove that can't be the case, because when you think about the way galaxies turn, our sun takes about 240 million years to go round once. And that means that it's gone round more than 50 times in the lifetime of our galaxy. And so if these things were strings of stars, it would have been wound up something like 50 times, maybe a bit less, but something like that. And it would look like a clock spring. Yeah. Not many people know what a clock spring is these days, but it's very, very tightly wound.
I know what a clock spring is, because my mum's dad, my grandfather, was a watchmaker, and I used to go into his workshop out the back of the jewellery store, and I just was mesmerised by all the mechanisms and he'd usually be sitting there on his stool with his eyeglass on, just working away inside these little watches and clocks. Oh gosh, he was brilliant. He was actually an instrument fitter in World War II for the RAAF up in the Pacific, and came home to be a watchmaker. Little sideline story. Yeah, it
is a nice story. But when you look at spiral arms in galaxies, they don't look anything like that. They've got these gentle curvature, and they're nothing like a wound-up spring. And so there's something else, though, that's really interesting. If you take an image of a galaxy using infrared light rather than normal visible light, what you're then seeing is all the old stars.
Oh, yes.
And the spiral arms disappear.
Yeah. Oh, really?
They disappear.
Wow.
So that leads you to the suggestion that it's the hot young stars, the blue stars, and in fact, when you look at spiral arms, they're often blue in colour, that you're seeing. They're the ones that make that spiral structure. So what it suggests, and they're short-lived as well, Andrew, that those hot blue giant stars, they only last for a few tens of millions of years. So what you've got is some process that actually triggers the formation of these stars in this spiral pattern, and then goes away. And that's what the answer is. And it goes back actually to the 1960s, to Chinese-born American astronomers Chiao Kia Chow, I think I beg your pardon, that's how his first name is. His second name is Lin. Chia Chow, Lin, and Frank Xu. Lin and Xu, they were the two people who figured out what's going on. And it's basically something like a sound wave that passes through the gas in a galaxy. And as it passes through, it triggers star formation, and you get these hot blue stars burning and shining brightly and then fading away. And this pattern then passes on. And it's almost an optical illusion, the spiral arms. They're formed from the hot young stars that are being compressed by the density wave. It's called a density wave as it passes through. And that actually turns out to be the right answer. Wow. That's what forms spiral arms. So it's far from intuitive. It's quite different, quite a different thing.
Indeed. I suppose you just look at them and say, well, that must be caused by the rotation, or it must be caused by some kind of gravitational effect. But no, it sounds like something completely different. And I believe not all galaxies have spiral arms, do they? Some don't.
No, that's quite right. There are, the elliptical galaxies don't they? And we think that's because the gas that they've evolved from the period when you've got a disk with gas in it that's making spiral arms. They're much older galaxies, or older, possibly even resulting from mergers between different galaxies.
Fair enough.
And then there are things called irregular galaxies, which are, irregular.
Yes. That makes sense.
Yeah.
All right. Robert, I'm sorry. Thank you so much for the question. Hope life is good for you in Poland. And we welcome your questions, of course, and please send them to us via our website, spacenutspodcast.com. Click on the AMA tab. I'm doing it right now, and it'll bring up the interface where you can either record your question by pressing the record button. That's how it works. As long as you've got a device with a microphone, you should be able to record. Don't forget to tell us who you are and where you're from, or where you're from and where you were from, as is the case with Robert. And underneath that, if you don't want to record your voice, you can do it through the email interface, where you can put your name and email and location and the question. Most I guess we could use that too. But it's all on our website, spacenutspodcast.com. Click on the AMA tab to send us your questions. We're coming up on an all-question episode. I think we'll do that next week, Fred.
That sounds right. Yes, I'll look forward to that. We've got some questions already in the bag, and hopefully we'll get some more by then.
Indeed, we will.
That'd be great.
But that wraps it up for another week. Thank you, Fred. Despite the trials and tribulations that no one will ever know about, it's a seamless episode of episode 243.
Maybe.
244
of
the Space Nuts podcast. We will see you next week. Thanks, Fred.
Sounds great. See you, Andrew.
Fred Watson, astronomer at large, part of the team here at Space Nuts, and back to Hugh in the studio, who's going to have a lot of fun putting this one together. And from me, Andrew Dunkley, thanks for your company. We'll see you again next week. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.